Welcome to this lecture on Subgraph of a Graph by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
So last time we started the graph theory, right? We introduced the what are graphs. So what was the definition of a graph?
Graph contains a non-empty set E together unordered sets of distinct edges.
Yes, a graph consists of two sets. First is a non-empty set B, and another is the set of unordered pairs of distinct elements of B, right? So the set V is called the vertex set, and the set E is called the edge set, and the elements in V are called vertices, and elements in E are called edges, right? Then we also had the diagrammatic representation of this graph, where we denoted the elements of the set V by small filled circles, and we joined two small filled circles if there is an edge corresponding to the two vertices, right?
Yes,
Okay. So today we are going to define what are subgraphs, and then we will also define what will happen if we remove one vertex from the graph, and what will happen if we remove one edge of the graph. So all these things we will define today. First, we will develop some terminologies before we can start using start proving some results. So we are going to define what are subgraphs. So let us just give its definition. A graph S is, so this should be a graph in itself. Okay, so graph S is called a subgraph of a graph G. So a graph is called a subgraph of another graph if the H set, if the vertex set of S is contained in the vertex set of G. Okay. Okay, so vertex set of S is contained in the vertex set of G. Every vertex in S is a vertex in G, and H set of S is contained in H set of G. मतलब इसके बाहर G के बाहर कुछ भी नहीं है S का. ठीक है? Basically it means that the vertex set of S is contained in vertex set of G, and H set of S is contained in H set of G. Is it fine?
yes.
Yes, sir.
So then S is called a subgraph of G. So that is a graph S is a subgraph of G if every vertex and edge in S is also a vertex and edge respectively in G. Okay. Now another definition. A subgraph. Oh, if F is a subgraph of G, if S is a subgraph of G, then G is called supergraph of S. Okay. If S is a subgraph of G, then G will be called supergraph of S. Fine. Yes.
Yes, sir.
Now definition 3. So another definition. Now we will define spanning subgraph. Spanning subgraph means that it contains all the vertices of G. Edges कम हो सकती हैं, but vertices सारे के सारे होंगी. ठीक है? So a spanning subgraph S of a graph G is a subgraph with Vs equal to Vg. That is, subgraph S contains all the vertices of G. एजेस के बारे में कुछ नहीं, एजेस कम भी हो सकते हैं बट वर्टिसेस सारे के सारे होने चाहिए, देन द सबग्राफ विल बी कॉल्ड स्पैनिंग सबग्राफ ऑफ जी. ठीक है, तो सबग्राफ S is called a spanning subgraph of G if Vs is equal to Vg. That is, every vertex in G is a vertex in S. Fine. अभी इन सबके एग्जांपल्स भी देखेंगे. लेट अस जस्ट फर्स्ट डिफाइन फ्यू टर्म्स. इसमें एक चीज और ऐड कर सकते हो. ठीक है, ये चाहे लिखो चाहे ना लिखो, ये बात एक ही है, क्योंकि सब ग्राफ बोल दिया है तो ऑलरेडी ये चीजें कंटेंट हो गई है, बट स्टिल यू कैन राइट इट ऑल्सो. ठीक है, now we are going to define as induced subgraph. So a subgraph in, let S be any subset of the, let G be any graph, let G be any graph, and S be any subset of vertex set of G. ठीक है, तो G कोई भी ग्राफ है, S is any subset of Vg. Fine. So then the subgraph induced by S, denoted by S, is the maximal subgraph of G with vertex set S. Okay, vertex set S. Maximal subgraph of G with vertex set S. Or that is, V of S is equal to S. Okay, so vertex set of this induced subgraph S will be equal to S, and E of S, इसमें सारे के सारे एजेस आने चाहिए. So S एक मैक्सिमल क्या होगा? All those edge in EG such that क्या आ जाएगा? Both and vertices of E lies in S. So सारे के सारे आ जाने चाहिए. ठीक है, Are you getting my point? तो मैक्सिमल मींस कि हर एक एज आ जाना चाहिए जो भी, जिसके भी दोनों एंड वर्टेक्स S के अंदर है. So that edge has to be in the induced subgraph of S. So S is called induced subgraph by S. The induced subgraph of G induced by S. So induced subgraph is the maximal subgraph with the vertex set S. Okay, is it fine? Is it fine? Is this definition clear or not?
Yes, sir.
Okay, fine. So now we have defined. So okay, one more is, so in other words, two vertices in S are adjacent if and only if they are adjacent in G. ठीक है, so सारे के सारे वो सारे एजेस आ जाएंगे, इसका मतलब जितने भी एजेस हैं जी के अंदर वो सब के सब एस में भी आ जाएंगे, जिनका भी एंड वर्टिसेस एस के अंदर लाई करता है. ठीक है, so this is what our induced subgraph means. It is the maximal subgraph with vertex at S. So maximal का मतलब क्या है कि हमारे पास कोई भी एक्स्ट्रा अब एज रह नहीं गया जिनको हम इंक्लूड कर सके सबग्राफ के अंदर, राइट? Okay, now we will define removal of a vertex or edge. Or an edge. We are going to define this. So how? Let us first define removal of a vertex. So let G be any, let G be a graph and V belonging to VG be any vertex. Okay. Okay. So then the removal of a vertex, the removal of vertex V from G results in a subgraph. So it produces a subgraph, results in a subgraph denoted by G minus V or G minus V. ठीक है, so कई बार ब्रैकेट लगा सकते हैं, कई बार नहीं लगाना है, वो इट डिपेंड्स ऑन आवर कन्वीनियंस. So results in a subgraph denoted by G minus V. और डिफाइन क्या होना चाहिए? Of G consisting of all the vertices of G except V, consisting of, so बस V को निकाला है ना हमने, so सारे के सारे vertices आएंगे except V, consisting of all the vertices of G except V and all the edges of G, all the edges of G except those which are incident with V. Okay, except those which are incident with V. ठीक है, so the removal of the vertex V from G results in a subgraph denoted by G minus V or G minus V, and it consists of all the vertices of G except V and all the edges of G except those which are incident with V. ठीक है, so induced subgraph के terms में क्या होगा? That is V of G minus V is equal to V minus V, right? And E of G minus V will be EG minus the set of all vertices in G such that E is incident with V, जिसका एक end point V है basically. So V is an end point of E. So we remove all those edges and then we get the graph G minus V. So that is G minus V is the induced subgraph induced by the set v माइनस, ठीक है, क्योंकि मैक्सिमल ही आएगा, क्योंकि बस वही एजेस हमने रिमूव करे हैं जो v से इंसिडेंट थे, बाकी सारे के सारे एजेस आ रहे हैं हमारे पास, राइट? इज इट फाइन? It is the maximal subgraph with not, it is the maximal subgraph not containing the vertex at v. That is g minus v is the maximal subgraph of g not containing the vertex set v. Oh, vertex v, sorry. Let me vertex v. Okay, fine. We have defined removal of a vertex. Now we will define removal of a set. Next definition is removal of an edge. Again, let G be any graph and E belonging to EG be any edge. The removal of the edge E from G results क्या होगा? In a subgraph denoted by G minus E or simply G minus E of G. So results in a subgraph of G consisting of, क्या होगा इसमें? इसमें से क्या क्या रिमूव होंगे अगर एज रिमूव कर रहे हैं हम? Consisting of all the vertices of G. So सारे के सारे vertices हो जाएंगे हमने, क्योंकि vertex कोई भी रिमूव नहीं करा है, ठीक है? And all the edges of G except E. So basically बस हम E को रिमूव कर रहे हैं और बाकी का सारा अपना वही है, ठीक है? और ग्राफ में से कुछ नहीं हुआ. वर्टेक्स में वर्टेक्स रिमूव करने से क्या हो रहा है? वर्टेक्स में रिमूव हो रहा है और साथ के साथ उससे जितनी भी एजेस इंसिडेंट थी वो सब की सब रिमूव हो रही हैं. बट अगर हम एज को रिमूव कर रहे हैं तो खाली बस हम वो एज को रिमूव कर रहे हैं. वी आर नॉट रिमूविंग एनी वर्टेक्स फ्रॉम द ग्राफ एंड वी आर नॉट रिमूविंग एनी अदर एज फ्रॉम द ग्राफ. सो बस एक एज कम हो जाएगा ग्राफ में से, ठीक है? That is v of g minus e is equal to v of g and v of, sorry, e of g minus e will be equal to all the edges of g except, fine?
Yes, sir.
Yes.
So g minus e क्या होगा हमारा? Will it be an induced subgraph or spanning subgraph?
Spanning subgraph.
Yes, it is not an induced subgraph क्योंकि सारी की सारी edges नहीं है इसके अंदर, right? So it is not a spanning subgraph, but it is a induced. Oh, sorry, it is a spanning subgraph, but not an induced subgraph, right? So note G minus E is a spanning subgraph of G, but not an induced subgraph of G. ठीक है? G minus V था हमारा, वो स्पैनिंग नहीं था, राइट? क्योंकि हमने एक वर्टेक्स रिमूव कर दिया. स्पैनिंग मतलब सारे के सारे वर्टेक्स आने चाहिए, ठीक है? और इंड्यूस्ड मतलब कि जितने भी वर्टेक्स हैं उसके कोरस्पॉन्डिंग सारी की सारी एजेस आनी चाहिए. तो यहाँ पे वर्टेक्स, लेकिन G माइनस E में क्या हो रहा है? वर्टेक्स तो सारे हैं लेकिन उसके कोरस्पॉन्डिंग सारी एजेस नहीं आ रही है, एक एज कम हो गया है. सो इट इज नॉट एन इंड्यूस्ड सबग्राफ, इट इज अ स्पैनिंग सबग्राफ, ठीक है?
Yes, sir.
ओके, नाउ रिमूवल ऑफ अ सेट. सो अब हमने वर्टेक्स डिफाइन कर लिया, एज डिफाइन कर लिया. नाउ वी वांट टू डिफाइन रिमूवल ऑफ अ सेट ऑफ वर्टिसेस और सेट ऑफ एजेस. क्या होगा उसकी डेफिनेशन? तो इसकी डेफिनेशन क्या होनी चाहिए? Yes, what should be the definition of this? Removal of a set of vertices. क्या होना चाहिए? हमने वर्टेक्स का डिफाइन कर लिया है, तो इसका क्या होगा डेफिनेशन? बताओ. Let G be a graph and S be a subset of VG. The removal of the vertices of S from G results in a subgraph denoted by G minus S of G with, इसका वर्टेक्स सेट क्या होगा? V of G minus S क्या होगा?
P minus S.
VG minus S. ठीक है. And what will be E of G minus S? It will be EG minus
All
the
those edges which are incident on any element of P of,
yes.
sorry, X.
So E is incident with some vertex in S. So we will remove all those edges which are incident with some vertex in S. ठीक है. So जो भी वर्टेक्स हैं जिनका एक भी एंड पॉइंट S के अंदर लाई करता है, तो उसको हम रिमूव कर देंगे हमारे G माइनस S के लिए. ठीक है. Is it fine? G minus S is the maximal subgraph with vertex set G OVG minus S, right? That is G minus S is the induced subgraph with the vertex set VG minus S. Fine?
Yes, sir.
Okay, now we will define removal of a set of edges. इसमें क्या होगा? क्या होनी चाहिए इसकी डेफिनेशन बताओ. Let G be a graph and S be any subset of. So S is basically set of edges. Then removal of edges in S from G results in a subgraph denoted by, तो इसको भी G माइनस S से डिनोट करते हैं, बट अब हमारा S जो है सेट ऑफ एजेस है, is with, इसका वर्टेक्स सेट क्या होगा?
PG.
Its vertex set will be equal to VG because we are not removing any vertex from the graph. We are just removing the edges. और EG क्या हो जाएगा?
PG minus S.
EG minus S. Okay, so we are removing all the edges that are in S. Okay, so this is your removal of set of edges from the graph. So let us now just see the examples जो भी हमने करे हैं. ठीक है, जितनी भी चीजें हमने डिफाइन करी है, let us see examples for that. So let us see this example. So first check whether G1 is a subgraph of G. Is G1 a subgraph of G? पहले vertices check करो, सारे हैं. V1 is there, V2 is there, V3, V4, V5, V6, V7, right? So all the vertices are there. Now edges देखो V1 V2 इसमें है adjacent, right? It is there. V2 V3 it is there adjacent, right? V3 V4 is there adjacent. V4 V6 is there adjacent. V6 V5 adjacent. V5 V6 or V5 V7 V5 V7 adjacent. V7 V1 adjacent. So it all the edges are also there. So this is the subgraph of G1, right? Yes, G1 is a subgraph. And what kind of subgraph is this? Is it just a normal subgraph or induced subgraph or spanning subgraph? किस तरह के subgraph है?
Spanning subgraph.
Spanning, because all the vertices are there, but not all the edges are not there, right? So it is a spanning subgraph. Spanning subgraph of G. Now what about G2? Just check G2. Is it a subgraph? देखो vertices तो हैं सारे उसके अंदर G के अंदर. What about edges? V1 V7 is there, V2 V3 is also there, and V6 V4 is also there, right? So it is a subgraph. Is it a spanning subgraph?
No, sir.
No.
sir.
Which vertex is missing?
V5.
V5 is missing. Is it an induced subgraph?
No, sir. An edge between V3 and V6 is not there.
Yes, you can show any edge. There are so many edges, but एक दिखा दो. So let us write proper reasoning also. Okay. So note that G1 is a subgraph of G. In fact, VG1 is equal to VG. So this implies G1 is a spanning subgraph of G, right? Also, इसमें कौन सा edges missing है? कोई एक edge बता दो जो missing है. V3 V6, right? ये दिख रहा है ना? Since V3 V6 does not belongs to E of G1, so G1 is not an induced subgraph of G. ठीक है? So it is a spanning subgraph, but not an induced subgraph. Now come to G2. G2 is a subgraph of G, but it is neither a spanning subgraph nor an induced subgraph, right? G2 is a subgraph of G, but it is neither a spanning subgraph. Why?
V5 is not there.
Yes, V5 does not
VG2.
belongs to VG2. ठीक है? And nor an induced subgraph of G. Reasoning: V3 V6 does not belongs to E G1. Fine. Yes. So our G2 is a subgraph, but it is neither a spanning subgraph nor an induced subgraph. Now what about this G3? Is it a subgraph? Is G3 a subgraph?
Yes, sir, it is.
And what kind of subgraph? Is it spanning?
No.
Is it induced? Yes, it is an induced subgraph. और कोई possibility बचती नहीं है जिसकी सारे के सारे इसमें भी सारे के सारे हैं तो इसमें भी सारे के सारे आ रहे हैं और कोई edges की possibility बचती नहीं है जो missing हो, right? G3 is a subgraph of G. Also, G3 is not a spanning subgraph of G as कौन सा मिसिंग है, कोई एक बता दो नाम.
V3.
V3, as V3 does not belongs to V of G3. G3 is an induced subgraph of G since it is the maximal subgraph of G with vertices V1, V2, V5, V7, right? यही थे ना?
Yes, sir.
So this one is spanning but not induced. This is neither spanning nor induced, and this is induced but not spanning, right? Is it clear? This one is spanning but not induced. This is neither spanning nor induced, and this one is induced but not spanning. Okay, so we have seen all the three examples. We have seen what spanning subgraph, which is not an induced subgraph. We have seen spanning, which is neither spanning, which is or neither induced, or this is induced but not spanning. अच्छा, जो दोनों होगा, जो induced भी होगा spanning भी होगा, वो क्या होगा? तो अगर हमारे पास subgraph है S, which is both spanning and induced, what will be that graph? What will be that subgraph?
G, G itself.
Yes, G itself. और कोई हो ही नहीं सकता, क्योंकि सारे वर्टेक्स आ गए, सारे एजेस आ गए, तो वो ग्राफ जो है वो G itself हो जाएगा. रिमार्क लिख लेते हैं हम. लेट अस रिमार्क if S is an if S is a subgraph of G, S is a subgraph of G that is both spanning and induced subgraph, then S is equal to G. ठीक है, स्पैनिंग की वजह से सारे वर्टेक्स आ गए, और क्योंकि सारे वर्टेक्स हैं उसके साथ इंड्यूस लगा दोगे तो सारे के सारे एजेस भी आ जाएंगे. ठीक है, यस, इज इट क्लियर? ये स्टेटमेंट सबको क्लियर है?
Yes, sir.
To others, Gaurav, Tushar, Hitesh, is it clear?
Yes, sir.
Okay, fine. Let us see the removal. अभी हमने subgraphs देख लिए, and now let us see the what removal means. Okay. So this is G, this is G1, this is G2, this is G3. What about G1, G2, G3? So what about G1? Is G1 a subgraph of G2?
Yes, sir. G1 is a subgraph of G.
किस तरह का subgraph है ये?
removing an edge. V1 V4.
So G1 is equal to G minus E, right? You just remove the edge E. ठीक है, बाकी सारा intact है. Yes.
Yes, sir.
Now what about G2?
G minus V.
G minus B. And what about G3? G3 is not a subgraph of G. Why? Because यहाँ
V1 and V3 are not adjacent to V.
yes, G में V1 और V3 adjacent नहीं है, but यहाँ पे V1 and V3 is an edge. ठीक है, V1 V3 belongs to EG3 as, but V1 V3 does not belongs to EG. So EG3 is not contained in EG. Hence G3 is not a subgraph of G. Fine. Okay, so this is G3 is not a subgraph of G. This is your G minus E. This is your G minus V, and not a subgraph. Fine.
Yes.
So now we have seen what is a spanning subgraph, what we mean by removal of one edge or a vertex. Now we will see some types of graphs. Okay, some types of graphs. Types of graphs. So थोड़े आज देख लेंगे, and then we will see some more graphs in our next few classes. So first is null graph or totally disconnected graph. ठीक है, so graph is said to be a null graph. क्या होनी चाहिए definition? A graph is graph G is said to be a null graph if EG is equal to phi. That is, no two vertices in G are adjacent. ठीक है, VG कुछ भी हो, but EG is phi. Okay, so there is no edge in the graph. That is, G a null graph is a graph G of size, and that is a null graph G is a graph with size 0. Order कुछ भी हो सकता है, size has to be 0. ठीक है, order means number of vertices, size means number of edges. So number of edges should be 0. ठीक है, एग्जाम्पल देख लेते हैं. So first is this V1, right? एक ही vertex है, or we can take two vertices, but there should be no edges. Or we can more vertices, but edges should not be there. ठीक है, So null graph of order 1, null graph of order 2. Order means number of vertices. Null graph of order 4. Fine? Is it fine?
Yes, sir.
So in a null graph, basically, so in a null graph of order n, what it means? Cardinality of Vg is equal to n and cardinality of Vg is equal to 0. ठीक है? और क्या बता सकते हो? Degree of
All the vertices are isolated.
yes, all the vertices are isolated, and degree of every vertex in a null graph is क्या होगा?
Is also 0.
A null graph is 0. Every vertex in a null graph is an isolate vertex. Okay. Now there is another type of graph. So we have defined null graph. Now we have so totally opposite graph, complete graph. Complete graph. Okay, denoted by Kn. So क्या होगा ये कंप्लीट ग्राफ, उसके अपोजिट टोटली अपोजिट बोल रहा हूँ तो क्या होना चाहिए डेफिनेशन? A graph G is said to be a complete graph complete graph कब होगा? If every pair of vertices in G are adjacent. सारे के सारे adjacent होने चाहिए एक दूसरे से. ठीक है? तो कितने एजेस होने चाहिए? So if a graph of order n is denoted by a complete graph of order n is denoted by Kn. A complete graph of order n is denoted by Kn. ठीक है? So in Kn number of vertices कितने होंगे? N order of Kn and number of edges मैंने बताया था ना कितने मैक्सिमम पॉसिबल एजेस कितने होते हैं किसी भी ग्राफ में. अगर कोई भी ग्राफ है NC2. ठीक है? तो अगर n इक्वल टू 1 है तो कितने मैक्सिमम पॉसिबल एजेस हैं? ये n ग्रेटर देन इक्वल टू 2 होना चाहिए. 1 के लिए तो वो चीज है. ठीक है? ये वाला फॉर्मूला तो दो एटलीस्ट दो एज वर्टिसेस होने चाहिए ना तभी ये होगा. सो K1 में एक ही वर्टेक्स है तो उसमें एज की तो एज हो ही नहीं सकता. ठीक है? In K1 there is only one edge, so there can be. Okay, so let us draw some edges. This is your K1. This is your K2. K3 क्या होगा? Yes, this is your K3. K4 क्या हो जाएगा? सारे एडजेसेंट होने चाहिए. So K4, ठीक है, one edge, इसमें one edge है, and 2C2 is 1, so one edge, 3C2 is 3, so 3 edges, 4C2 is 4C2 is 4 into 3 by 2, so which is 6, right? So 6 edges. और कोई पॉसिबिलिटी भी तो नहीं बचती, देखो हमने सबको सबसेटिशन कर दिया, इसको इन तीनों से 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 कर देते, और कोई पॉसिबिलिटी बचती नहीं है जिसकी, ठीक है ना। सो K5 में कितने एजेस होंगे बताओ कोई। नंबर ऑफ एजेस इन K5 10, ठीक है। K5 इस तरह का बनेगा, 5 वर्टिसेस ले लिया, फिर सबको ज्वाइन कर दिया। ठीक है, so this is your K5, right? With 10 edges, 10 edges, 6 edges, 3 edges, 2 edges, oh sorry, 1 edge, 2 vertices, 0 edge, ठीक है। So this is these are all complete graphs. Every pair of vertices are adjacent. Okay, so this much is enough for today. Okay, in the next class we will learn some more types of graphs like bipartite graphs. Then we will also learn about complete bipartite graphs. Then we will learn about your there are more cycles and all those things we will learn in the next class. Okay, now this much is enough. Any questions anyone want to ask? Okay, so as there are no questions, I'm ending this class. Okay, so bye everyone, have a good day.
Thank you, sir.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.